Hello there, Mr. Sutton here, bringing you the Algebra 2 Honors 8-6 Part 2 homework solutions on applications of permutations and combinations. For this problem, we have a team of 25 rowers attending a tournament. 5 rowers compete at a time. We want to know how many combos of 5 rowers are possible. So we're just doing a simple count, and we're looking, they literally said combinations. But we always have to double check the way that they use this word. Does it matter what order these 5 rowers are selected in from the 25 rowers? It actually doesn't, because they're competing. It doesn't really matter maybe what their placement is. They're just all together. So order doesn't matter, which means we can actually use a true combination. We're going to have 25 choose 5 for our setup on this. And let's go to Desmos to plug that in. So we can get combinations by doing n capital C R, n choose R, parentheses, and then our n and our r, so 25, comma 5, gives us 53,130 different combinations of rowers. That's insane. For this problem, you and your friend are 2 of 8 servers working a shift at a restaurant. At the beginning, the manager randomly assigns one section to each server. We want the probability that we are assigned section 1 and our friend is assigned section 2. So we're looking for a probability. That means that whatever we do, we're probably going to be finding the total possible outcomes with our permutation or combination. And the fact that we specifically want to be assigned to section 1 and our friend to section 2 means the order does matter in this 2 people that are chosen. Since the order matters, we're going to use a permutation to find this total possible outcomes. So we're going to do 8p2 to get that. And going to Desmos for that, let me do npr parentheses 8 comma 2. That does that does my 8p2 sort of thing on Desmos. That comes out to 56. So there's 56 different permutations for what those first 2 servers can be. Only one of those is going to have us in section 1 and our friend in section 2. So our probability then is going to be 1 over 56. On this one, we have 11 students competing in a graphic design contest. How many different ways can the students finish first, second, and third? So we're just doing a count here of number of ways. And since we have first, second, and third, the order matters. So we're going to need a permutation for this one. We have 11 total, and we're picking 3. So 11p3 is the setup. Let me go to Desmos, and then let me do 11p3. So npr, parentheses, 11.3. And that comes out to 990 different ways that we could have students finishing first, second, and third. For this problem, you and your friend are in a studio audience on a game show. From an audience of 300 people, 2 people are randomly selected as contestants. What's the probability that you and your friend are chosen? Well, we're looking for probabilities, so whatever we get, it's going to be a total possible outcomes sort of thing that we'll then have to put in a probability. And to count the total outcomes, if we're just picking 2 people, and they're both going to get to be contestants, probably the order doesn't matter so much here, so we can just use a combination. So we're going to have 300 choose 2 as the setup for this. Let me go to Desmos for that. So we're going to do ncr and then parentheses 300 comma 2. And there are 44,850 different combinations of people that we could pick, and you and your friend are just one of those, so 1 over that number is going to give you your probability. In this problem, they want us to use the binomial theorem to write the expansion of a plus 3b quantity to the 4th. So let me write our binomial theorem formula. That would be ncr, and then we have a to the n minus r and b to the r. So just going through here, we've got an n value for all of these of 4, and then the r is going to start at 0, and it's going to make it all the way up to 4 by the time we get to the last term. So we've got 4 choose 0, and then a to the 4 minus 0, so a to the 4th, which is literally a in this case. A is a. And then we've got b, which is this 3b actually, to the 0 power, because it's the r value is 0 for that first term. And then the exponent on the a and the b are going to, as one goes up, the other is going to go down. So our next term, we've got 4 choose 1, a to the 3rd, 3b to the 1st. After that, we have 4 choose 2, a to the 2nd, 3b to the 2nd. Next, 4 choose 3, a to the 3rd, or 1st rather, 3b to the 3rd. So again, the first exponent's going down, the second's going up. And then I ran out of room, so I'll write my last term here. 4 choose 4, a to the 0, 3b to the 4th. All right, let's go through and we'll do 2 waves of simplifying here. So let me do first the 4 choose 0. Anything choose 0 is 1. Only one way to choose nothing. And then we've got a to the 4th. And then 3b to the 0 is just 1. For our next set here, n choose 1 is always going to be whatever the n is. So 4 choose 1 is 4. We have a to the 3rd and 3b. Next, 4 choose 2. Let me go to Desmos for that. So NCR 4 comma 2 gives me 6. And then we have a squared, and 3b squared is really going to be 9b squared. Next up, 4 choose 3. In general, n choose n minus 1 is just going to be whatever the n is, because now we have n ways to leave out one item. So that's just going to be 4. But you could plug it in the calculator if you want. And then a to the 1st. And this will be 27b cubed. And then for this last one, 4 choose 4 is going to be 0, because n choose n is always 0. Or not 0, 1 I should say. It's the same as 4 choose 0. a to the 0 is 1. And then 3b to the 4th is 81b to the 4th. Last wave of simplifying. Let's clean this up a bit. This first term is just a to the 4th. For the next one, we've got, let's see, 4 times 3 is 12, a cubed b. Then 6 times 9 gives me 54, a squared b squared. 4 times 27, let me do this without a calculator, that's 108, ab cubed. And then finally, this is just 81b to the 4th. For this one, they want us to use the binomial theorem to expand c minus 4 to the 5th power. So again, here's our binomial theorem formula. So we're going to start with an n value of 5 and an r value of 0 and work our way up to r equals 5 as we go from one term to the other. So let's start with 5 choose 0, and then we have a to the 5 minus 0, so a to the 5th. In this case, a is really c, so c to the 5th. And then our b value is negative 4, so that's going to be negative 4 to the 0 power. Next up, we've got 5 choose 1, c to the 1 exponent lower, so c to the 4th, negative 4 to the 1. Now we have 5c2, c to the 3rd, negative 4 to the 2nd. Next, 5 choose 3, c to the 2nd, negative 4 to the 3rd. And now we have 5 choose 4, c to the 1st, negative 4 to the 4th. And finally, 5 choose 5, c to the 0, and then negative 4 to the 5th. All right, let's simplify one round here. So 5 choose 0 is just going to be 1. We have c to the 4th, or 5th rather, and then anything else to the 0 is just going to be 1. Next up, 5 choose 1 is just 5. We have c to the 4th and negative 4 times all that. Next, 5 choose 2. Let me go to Desmos for that. So I'll do n capital CR and then 5 comma 2. That gives me 10. So we have 10 c to the 3rd. Negative 4 squared is 16. Next up, 5 choose 3. Let me just change that 2 out for a 3, and that's also 10. C squared, and then negative 4 cubed is negative 64. 5 choose 4. This is an n choose n minus 1 situation. It's just going to be whatever the n is, so that's just 5. You could plug it in though. We have c to the first, negative 4 to the fourth. Let me plug that in. Negative 4 exponent 4 gives me 256. And then 5 choose 5 is just going to be 1. C to the 0 is just going to be 1. Negative 4 to the 5th power, let me change that to the 5th. That's negative 1024. All right, one last round of cleanup on all this. So this first one is just c to the 5th, which is kind of nice. Next up, 5 and negative 4 gives me negative 20 c to the 4th. After that, we have 160 c cubed, positive. Next, we have minus 640 c squared. And then we've got whatever 5 times 256 is. Let me figure that out. 5 times 256 is 1280, so plus 1280c. And then finally, minus 1024. And that is done. For this one, we are trying to figure out the x to the 5th power coefficient if we expand x minus 2 to the 10th power. So we're going to use the binomial theorem here in order to kind of shortcut that whole process so we don't have to do Pascal's triangle and write everything out. So let's first find the n and the r. The n is the 10 there, the highest exponent. The r in this case, since we just have x to the first power, r is just going to be whatever the n is minus the p. So 10 minus 5, which is also 5. So I've got 10 choose 5. That gives me this term that I'm looking for. And we're going to have x to the, let's see here, 10 minus 5 is going to be 5, so x to the 5th, which is what it should be because we are looking for the x to the 5th. And then our b value is going to be raised to the r, which in this case was also 5. So negative 2 to the 5th. Let me do 10 choose 5 on the calculator. So NCR, parentheses, 10 comma 5, which is 252. We've got x to the 5th. And we've also got negative 2 to the 5th, which is negative 32. So to get the final kind of term here, I need to do negative 32 times 252, which is negative 8,064. And we have an x to the 5th kind of along for the ride. But the part I wanted was the coefficient of all this, which is negative 8,064.